Welcome to this dbWatch webinar, where we will focus on MySQL Server performance and how you solve and identify that with dbWatch Control Center. Today, my name is Per Christopher Undheim. I'm the product manager for dbWatch Control Center, and with me today I have Marek Jablonski, Chief Technical Officer at dbWatch, and with 25 years experience in developing and using dbWatch for performance analysis on systems. This webinar today, we will focus on getting the SQL Server performance monitoring jobs installed and set up and configured in dbWatch Control Center. We will see how data is collected, how we use it to capture and analyze SQL performance, depending on the focus area you have for your SQL statements. We will look through the visual performance insights to use the graphs and use the dashboards in dbWatch to analyze SQL activity. And we'll also show how posterior growth are monitored and trend views for all systems using farm views. Please, Marek, can you take it away and help educate our community?
Thank you, Per. I will start first to show with introducing to the dbWatch product for some of the users who are not so familiar with the product. So just give me 2 minutes and I will just show you how dbWatch Monitor works and what you can find there before I start with the performance monitoring jobs. So this is monitoring view in dbWatch. You can see the list of the instances on the left side and all the warnings and alarms we have on those instances. You can also see the list here with some information about each platform. You can then select one of the instances and see all the jobs installed and the statuses from those jobs. So this is the monitoring part, and we'll spend some time here looking at the performance monitoring jobs. And then you can switch into the management part. Here you can interact with the database. You can see the database, see the database files. You can do the normal administration, very similar to Management Studio. So this is the management part. Then we have farm views. It's a different way of looking at the whole environment, where we can see different metrics about the whole environment you are monitoring. Then we have a worksheet where you can run SQL statements against one or many instances at the same time, depending, of course, on the platform. So this is the worksheet. You also have a worksheet in the management section. Then you have the auto discover. So dbWatch Server can actually scan the network and see if there are any other instances which are not monitoring, which you may add to your system. So scanning. Then we have the FDL console. This is the internal query language in dbWatch, where you can, it's lying on the top SQL language. So we just run not like this. Then I execute and get some information. If I type this out, select this, and I get a query back. And also we have reporting, so you can select some instances around some reports here. One of several reports. So that's a very short introduction to the dbWatch Monitor, and we are going to use this, of course, products when showing you the performance jobs. So let's get back to the presentation. So just a few more slides before we go back to the monitor. It is important that you have the extra license for that jobs. So the instance you want to monitor and do the performance analysis, you will have to enable the SQL Performance package. Otherwise, you won't be able to install those jobs. So when the performance package is enabled on the instance, you will have 3 dedicated jobs which can collect the performance metrics for resource demanding statements. In addition, there are a lot of other jobs which collect broader system and instance performance metrics, which are where you don't need the performance license. Those 3 jobs I'm going to talk about today is SQL Statistics job, blocking event collector job, and session SQL event collector job. So those jobs collect statistics related to SQL statements run on your instance. There's also a job named Session Statistics, part of this performance package, which if I have time, I will show you how you can use it. It's more just to collect information who is logged into your system and from what machine and what applications used against what database and so on, which is very helpful often to narrow where to focus on. For blocking event collector, we use the extended event to capture those blocking events. So it means that the SQL Server is responsible for capturing those events, and dbWatch job is just reading those external files, getting data back into the dbWatch database for analysis. So this is the blocking event. SQL Statistics, for that we are taking snapshots of data from those dynamics management views. Every 5 minutes we just check what changed since the last run and collect those statistics in dbWatch database. And the last one is the Session SQL Event Collector, where we also use the extended event. So once again, the SQL Server is responsible for capturing statements which run for longer period of time. So I will focus mostly on those two first jobs, but I will also show you how to use the last one. And of course, there's a lot of other jobs which collect different metrics, which are nice to have when you analyze SQL performance. It's nice to know the CPU usage, memory usage, and other important metrics analyze your system. And all those jobs you will find in the performance group in Monitor. So let's switch into the live demo. As I told you, that we'll start with blocking event collector job. So I will look at the configuration and how to read the data where the data is captured. So let me go back to Monitor. Since we are focusing on Microsoft SQL Server, I will change it to a different view here. Here I have all my SQL servers, and the SQL Server we are going to work with today is my local SQL 2022 instance. Here I have already installed the blocking event collector job. To be able to install it, you will have to enable the license. I will just show you quickly. So configure instance, and yeah, here it is. And you will have to enable the SQL Performance package to be able to install that job. As soon as you install the job, the extended event is created, and the default location where those trace files will be created is in the log directory. So we recommend that you change it to someplace else. So that's the default value, and also the default value for block threshold is 10 seconds, which is quite short, but you will be able then to catch all those short-living and blocking events. So this job, as soon as you install it, you can change the path before or after. If you change any configuration of that job, this extended event will be defined once again with new values. And the blocking job is just extracting the information from the operating system file. So those files will end up on my computer. It's here. So that's the files created by extended event. So when the blocking event appears, after 10 seconds, the SQL Server will write a record to that file, and every 10 seconds if this session is blocked. So this is just a job collecting the statistics, and if you want to analyze and look for read those statistics and see what kind of events were captured, you have to switch into the management part. So I will also switch into the by type SQL Server, and here is my instance. And if you install this job, you will see just under server activity, there's a view blocking events view. If you don't install this job, this won't be visible at all. So if I go to a different instance here, like here, and look at the server activity, you can see the blocking events, but there's no blocking blocking events view here. So let's go back to this one. Before I explain what you see here, I just want to start a session and another transaction, and start actually two transactions where one of those will block the other. So I have two sessions here, one with Marek and one with Per, and I will start a transaction, one of them here, like this. So here I update around 500,000 records, and now I go back here and I start a different transaction like this. Okay, and you see that this session is waiting for the. Okay, as soon as this happens, you can actually go into the monitor. There's another job which just checks if any session blocked. You can run it and see it. There is actually a session waiting for another. Nothing happens here because the information will be after 10 seconds. The data will be saved into those trace files, and then this job will read those files, those statistics, back into the database. So we just wait for a few seconds. So I will go back here. So what you see here, you can already see that did have some blocking events yesterday, also today here, a few hours before this webinar. So here you will see all those blocked transactions. You can narrow to, let's say, I can take a look at those here, and you can see, okay, here we have 3 transactions which were blocked. You can see the shape of the curve is a little bit bent because we are using the logarithmic scale on the y-axis, and the reason for that is that it's easier to see long event transaction together with short-lived blocking event, just to be able to see many different waiting time values. So here we have the transactions. There's another graph which shows the per statement. So here is actually the same statement blocked. So sometimes it's nice to see, is this the same statement blocked all the time? So here's the graph which shows you per statement, and here is per transaction. And the same, the table below, the first table shows you all the blocking events per transaction. So every blocking event is a transaction. And here you can see per statement. So this statement was registered 3 times. So let us just go back and see what's going on. Here you can see that just 2 days. Now you can see that the blocking session which we just started, the background, it's registered here. So you can see it looks like that. So if the session is still blocked, it will have this shape which just bends to the right and just get broader and broader. So this is the session right now. Let's go back to here. So here on my blocking session, once again, I can focus on those 3 once again. Here I have some information about the blocked session, the login, the host, and what program, and so on. And on the right side on the table, the information about this session, which is blocking. It's a Marek and same application and so on. And also you can see if the execution plan is captured or not. So here you see actually that the first transaction we're not able to capture the execution plan, but the second and the third we were able to capture the execution plan. So now you can click here and let's say show statistics. Let's say if I look at this one, and I will see this. That's the last one. Yes, this is the last block session, and also I can investigate the query plan here like this one. I can also switch into that table. So now you see, okay, there's and I can see this. And I can take a look at statistics for all those statements. There's one statement that 3 times captured. Now you will see the graph like this. So you see part per transaction, or you can see it per query plan. So if you say that we use the same query plan for second and third, but for the first one we actually didn't capture the query plan. So that Also, you see it in a different column. But the important thing here is that you actually check the query plans, because you can capture the same statement which is blocked, and at the same time you can see that the system is using 2 or more execution plans, and that's something very important to see. Okay, I have the blocking statement. Okay, is the query plan changing from transaction to transaction? Important information. So let's go back to our blocking event. I will take a look at the last 4 hours. You can see it's still blocked here. I will probably get some warning here soon, and we switch back. So now I will stop this, or at least commit this transaction, so the lock will be released. Let me commit transaction like this. And now we can see that this one finished, and now we don't have any blocking session anymore. I can switch into the monitoring. I'll run this one once again. Obviously, no blocking sessions, and then this will be, so the new information will be saved in those trace files, and here I can run this job, and new statistics will be collected from those trace files. And here, and at some point you will see that this blocking event ended, and it's almost there. I will just run once again like this, and see it would always take a bit longer time before it's saved into the dbWatch tables. So this is how you can look at the statistics captured by this extended event, and do your analyze statistics here. Also, below here you will have statistics from different jobs, like for example workload is a different job which is also collecting some performance data at the same time, so you can compare if there's any connection between the blocking and the workload, for example. So this one, if you go to monitoring, you will see that this is the job which is responsible for collecting those statistics. So together with the blocking event statistic, you will also have some other jobs which show the different metrics which may be relevant or not. Now we can see that this one is finished here. Yes, let's go back. Before I go to the next job, I will just show you the internal repository for that job. What is important is that this job, this blocking event collector, is not using too much resources. Remember, it runs every minute and tries to read that file. Usually it takes just a fraction of a second. So here I will use just less than, this is in milliseconds, so it's less than 1 second, and that's normal. But be aware that sometimes it can run into some other problems, and this job will be using too much resources. So check this graph to see that the execution time for that job is not consuming too much time. You'll also find some information about how this extended event is defined. So you can take a look here. You can see when it was created. You can actually run it, execute it once again. Don't do it, but there's a possibility to recreate this extended event. And also you have different statistics. It shows you the name of the file, when it was read first time and last time, and how many times it was actually read by dbWatch application, and so on. And here also some statistics about data collected. So you can see it collected one record and another record, and so on. Here is the total amount of records or blocking events collected by this job. So let's go back to the presentation. So, okay, that was the blocking event collector, which gives you some insight about the application running on your system. Again, it captured quite short-living blocking events, so 10 seconds is quite short. We recommend that you maybe increase this threshold to a minute or so. Here I have some screenshots from the real life production site. So you can see the Here are some blocking events on one system. You can see some of the blocking events were lasting for many minutes. Some of them were very short. And since we're using the logarithmic scale, you still see it very clearly. You can see the short blocking events and some long in the same graph without any problems. Then you can click on one of them and get some information. Like this one, this little spike. You can say, okay, that's the blocking event. You can see how it was just 11 seconds, it was just on edge, just detected barely, and you can see the statement. Then you can click at the execution plan and see, okay, is it the way it should be, and so on. So you can analyze those blocking events for yourself. The next job I would like to show is the SQL Statistics job, which is based on the snapshot of the Dynamics views. So let's switch to once again and take a look at those. So this is the monitor once again, and monitoring part, performance here. So blocking event, that's the job we were just discussing. The other one is here. This is a SQL Statistics job, which runs every 5 minutes per default and checks and trying to read those statistics of those different statements in memory into the dbWatch database. This job will collect quite a lot of information. Per default, it's not collecting execution plans, and we recommend to not use it at once, maybe later. So use the default setup. In default, it will read every execution plan for every new statement registered in dbWatch and check if there are any missing indexes. And if there are some missing indexes, then the execution plan will be saved for that statement. So that should probably do. Very often the amount of data can be quite large, 10, 20, even 30 gigabytes of data. So be aware that the dbWatch database will grow a lot. Without the performance package, the dbWatch database is maybe 50 megabytes. It's quite small. But as soon as you start to use performance package, this database will grow a lot. Per default, it is maximum 10 gigabytes, and 80% of that space is possible to use for this job. So be aware of that. So if it grows beyond that, the job will continue, but it will go in warning and tell you that the repository is too big. So you can increase maybe the number of days you are collecting data for, or you just increase the database. The only thing you have to do is to increase the maximum size, and dbWatch server will do the job, will increase the maximum size of dbWatch database, and everything will go back to normal. So once again, so this one is just collecting statistics. So to be able to see what's this job captured, you have to once again switch into the management part. So we go to the management part, and if the job is installed, then you will have this one here. If the job is not installed, you won't be able to see this panel at all. So the main graph shows you the total number of logical reads and logical writes and physical reads for all the SQL statements collected by that job. So this is the sum of all of those. At the same time, it will capture the amount of wait time and worker time and so on. And the waits and CPU are collected by different jobs. You can also see the statistics here below. But this is captured together with those different SQL statements. So here you have the main graph. You can then select the time frame and could focus on some period of time and see if we find a statement which is responsible for that spike, for example. So the table below is showing you statistics per SQL handle during that period. And SQL handle could be one statement, but it could be a set of statements. So, for example, here, it's not easy to see it at once. So let's say we can select one of those. It's sorted by logical reads. So this one is responsible for most logical reads during that time period. Take a look at this one. Right click and show statistics. And now you can see the spike is here. You can see the statement responsible for that. sometimes you will get empty tables. So you have to refresh the information here. So here you can see that this SQL handle, there's just one SQL statement, so insert with a subquery inside. So there's just one statement here. You can also see the same statement here, and you can also show the statistics once again here. And the statistic will be identical because there's just one statement. But it's completely different if you look at the more complex SQL handle, like here. If we look at the statistic here you can see that this handle is actually a procedure, and in that procedure there is a set of many different DNL statements. Those statements you can actually see on the right side here. But here in the graph on top, you see the total amount of logical reads and logical writes and physical reads for all those statements during that period of time. And then you can click on it's this one. Okay, there was a delete from and so on. And you can see the whole statement here. And you can see, okay, how much resources was this statement using during that period. So you can see, this is the amount of logical reads and so on for that statement. Once again, you can refresh to see, you can get some data. This is at least the statement, and you can see the amount of resources here. So it's just a fraction of resources to compare with the others. Of course, you can sort it by logical reads, for example, like this. So this is on the top, and show statistics. And now you can see the amount of logical reads. Maybe I didn't. Okay, if I take a look at this one, the statistics, you can see the amount of resources used by this statement, this insert with subquery. So here you can, so it depends what kind of SQL handler it is. It can be as simple as just one statement, or it can be a set of statements. And we have statistics for all those statements inside the handler. So the information you have here in the second column indicates if it's code related to dbWatch. So of course, on my system, I just run dbWatch. So that's why all resource demanding statements are from dbWatch server. And there's some statistics related to all those statements in that handle. And also we have two columns here. One is telling us about missing indexes, and the other one is telling us if multiple query plans were used. So let's take a look at that. So right click again, show statistics. And so here is the so this is actually the procedure which collects this statistics, and here we have all those statements inside the procedure. You can see them on the right side, and here we can see that some statements where SQL Server recommend index, and also it says that for this update different query plan were used. So it's something important to investigate and check why I'm using missing indexes and why I'm using different execution plans. So let's take a look at this one. We'll show also here we can actually select missing indexes, and you can see what SQL Server is recommending. So there's, and here actually you can create also the index if you want, and so on. But let's take a look at the so they will show missing indexes, show statistics. Okay, like this. So now I'm looking into this statement. So that was an update, and we saw that we were missing indexes, but also let me see. Here it is. So we were missing indexes, but also there were different execution plans. Here the query hash, so you can see that during execution of that statement, system was using different query plans. And here you can right click and see the query plan. So here it looks like this one. Sometimes you get several values. they're almost identical, but there should probably the query plan is identical, but there are some different values here, and that's why we are capturing both of them. So this is one of the plans, and here's another one, the query plan here. And then we can see that the plan is maybe a little bit different. There should be some differences. And we can here's a different query plan like this. Yeah, I mean there's not many different. There's some differences and something to investigate. So with this job, you can look at those different statements captured by dbWatch. We will see if the execution plan is different, or you are missing indexes, and you can do something with that if you want. So that's about SQL statements. That's about this SQL statistic job. And also very important part is the internal repository. As I told you earlier, this job will collect a lot of data in dbWatch database. So in my case, it's still quite small database, but on a production system, you will easily get 10, 20, even 30 gigabyte of data. So just be aware of that. But the important thing is this graph, which shows you the execution time of the job. So it shouldn't take more than 10, 20 seconds. Remember that this job runs every 5 minutes. So if you spend 1 or 2 minutes every 5 minutes just to collect statistics, that will be too much. So it depends on how much statistics are available in the memory. For example, here on my system, I just have few. I mean, here 600 and 100 SQL statements, handles actually in memory. Of course, one hand could be tens, maybe even 100 of statements. So that's on my system. But if you look at the production side, you could see that you have 100,000, maybe even 200,000 SQL handles in memory, and that's quite a lot. dbWatch is reading all of them, but not saving all of them. There's a parameter named mean logical read. I put 0, so I'm actually collecting all of them, but this one is usually the 100 logical reads. So if the statement is using less than 100 logical reads, that's close to nothing. There's no point of collecting information about statements which are not using any resources at all. If this job is using too much time, I would recommend to increase this threshold to maybe 10,000 logical reads and so on. So you're not analyzing all the statistics, but take a look at the execution time. It shouldn't be over 10-20 seconds. Here in my case, it runs 2, 3, 1 second and so on. So it's quite fast, but it's a very small environment. So keep eye on the repository site when you the performance, SQL Performance or SQL Statistics job, because this one may use some resources, both the CPU and space. And of course, if there are some resource demanding statements running by dbWatch, you will see it here. It will be indicated by this check icon. So you see, this is a job which is responsible for using a lot of resources. Yes, so that's the SQL statement. So let's go back to the PowerPoint. So we have been discussing the SQL statistics. Here I have some screenshots also from production. So you can see some spikes, some physical reads. Here you can see, you can then click on some statement here and see, okay, this small spike was responsible for, or this SQL statement was responsible for this spike. And you can see, okay, some missing indexes. You can check, okay, what indexes were missing, and from here we can create indexes or make a note that, okay, there's a statement which probably will index or not. So that's those two jobs. The third one, this Session SQL Event Collector, I would recommend to use it as an add-on to other jobs. So let me just switch to monitor and show you how it looks. Back to the monitor here, and SQL Event Collector here is the job. This job, you have to configure it to get some statistics, because when you install it, it's not collecting any statistics before you configure for a specific database. So those two other jobs I was talking about, they work out of the box. You don't have to do any configuration. We recommend that you do after you use them, but they work at once. As soon as you install them, they will start collecting data. But this one, you will have to specify what database you want to collect statistics for. And you can specify the list of databases. We recommend that you not make this list too big. 2, 3, 4 databases, it's okay. Here we use also the extended events. So all information will be saved to an external file, and we are then reading those data back to the database. And this job is just capturing statements which use longer time to execute. The threshold is 200 milliseconds, so 0.2 seconds, so it's quite short. So you can specify if there is any statements which use more than 200 milliseconds, you will capture this event. But the important thing is that if you have a lot of blocking events, they will use a lot of time, and they will be also captured by that job. So we recommend that you first work with the blocking event collector, see if you have a lot of blocking events, and resolve that problem before you use session SQL event collector, because then you will get a lot of information about those blocking events. Okay, they use a lot of time, but they are not executing. They're just waiting for lock to be released and to continue executing the transaction. So let's go to the management part. And so if this job is installed, you will have this one available. So you can see what was captured here. I can take a look, and that's the last 8 hours. So you can see all the statements captured during the last 8 hours, and how much time the transaction was using. So this is duration in seconds. So some of them quite short. This is just less than 300 milliseconds, so just above the threshold. But the other one is not just that they are executing for a very long time. Let's say we can take a look at the code, and we recognize the code. That was the code I was using to trigger the blocking event. So that will be a little bit give you wrong information, because they are using a lot of time because of the blocking event. So yes, this is a nice job to use for a specific database. You can see which database this is configured for and where those statements were captured for which database. But use it after you are resolving a problem with blocking. Otherwise, you will get just a lot of blocking events, statistics, which we should analyze in the different view. And also you have the repository here, but usually it's not the problem. I mean, it can grow to some size, but there's not that much statistics collected. We are not collecting any statistics for execution plans and stuff like that. Just the statement will be captured, which is using a long time to execute. So that's the third one. The fourth job, before we go to farm views, I would like to show you the last job, so-called session performance, which is not capturing any information about SQL statement. It captures actually information if it's the update or delete of this kind of information, but not the statement. But this is quite nice to see what was connected to your system when you look at some performance data and the resources were consumed by those statements executed on the system. Then you can say, okay, who was actually logged onto the system? So you select the period of time. Then you can see all the sessions connected here. You can see what host, what kind of program. So here is, of course, just dbWatch, and some information, how much CPU those sessions will be using. So you see after the CPU usage, the elapsed time, E, and so on, and logical reads for all those sessions during that time. And here you also see, okay, what programs were connected to the system. Okay, there's unknown, so we don't know what it was, but you can see the other programs. You can see two sessions when we were creating the blocking event. You can see the databases used to the session were connected to during that period. You can see logins, hosts, So there's a lot of information you can get here, and social statistics, so you can get some more information about that session. So you see CPU time and lapse time, those statistics captured during extracting the data. So this is also quite nice job which collects information which can be very helpful when you're analyzing performance, because then you know, okay, where are the connections coming from, what program are running on the system, and then you can try to see if those statements which you are analyzing are related to that program and so on. So that's those 4 jobs. So let's go back to the presentation. So what happened if you have a really large system, you have 100 of instances, or maybe even 1,000, and you install this performance module on many instances? It's nice to just get the overview where you should start to do the analysis of your system. Where do you have all those blocking events, and how many, and so on. And for that, you use farm views. So if we go back to the monitor, and back here, so here we have farm views. If we take a look at the blocking events here, so now you can see, okay, this job is installed on 4 instances on my system. I can see execution time, so I have the averages of okay. I can see some statistics from those, and I can see blocking events. So you can see here a number of blocks events detected. So on this instance, I have already 170 blocking events detected. So of course, if I want to start analyzing blocking events, I would go to that instance and investigate, okay, what's going on there. And here I just have 5. I can see last time captured blocking event, that was 2 days ago. This one was the one we were triggering during this webinar. And those 2 instances don't have any blocking event, even the job is running, but there were nothing, no blocking events detected. So this gives you an overview where to start. And if you have 100 instances, then it's easy to see which instance you should start with. And the same with SQL Statistics here. So this one is installed on 5 instances. You can see the average execution time, so it's okay. I think it gives you 50 seconds. And if it's more than that, you get kind of a warning. You will also receive the warning from that job if the job is using too much time. And also you see the amount of space used by those repositories. So in my case, I'm using just very, very little space to compare with 10 gigabytes. So it's very little. But this gives you overview if the job is performing correctly, if it runs fast enough, and if it's collecting enough data, and so on. So that's the farm views. So let's go back to the presentation, and yes, that already did, and that's actually all for today. So I have been discussing those 4 jobs which you need extra license for, and as soon as you install them, then you can start collecting data and get some information about that. Yes.
Yes, we have some questions also from the attendees. So dbWatch is collecting stats. It's around the query store, and is that used for this type of setup?
No, we do not use Query Store. There's different reasons for that. Remember, dbWatch is multi-platform product, so we're trying to create this performance views and the way we collect statistics the same way for Oracle, Sybase, and other platforms. And very often those Query Store are not enabled on the customer side, and the Query Store is per database. So then you have to configure it for database. So if you have 50 database on the instance and you want to monitor all of them, there will be a lot of configuration and maintenance for all of them. So that's why we just decided to use to create our own and collect statistics from all independent on the database. So the answer is no, we are not using the Query Store. There's a job actually which is checking if the Query Store is on. So when you use this SQL Performance, then you can see, okay, the Query Store is on, so you don't interact with each other. But you can use both. There's no problem. But we are not using it. No.
Great. Also a question on deadlocks. If deadlocks is monitored that way, or how do we monitor deadlocks?
Yes, the deadlock, we can monitor deadlock. Let me switch to monitor. It's not a part of performance. It could be. There's a job name the availability in the deadlock event collector, where we also use the extended events. So as soon the deadlock is captured by the SQL Server, it will write to the external file, and this job reads that file from time to time and see is there any deadlock captured by SQL Server or not. So it's under availability. Yes, and we just capture and read, and you get a warning telling that the deadlock was detected or something like that. Let me see, deadlock event collector. Yes, you can see. Yeah. So the answer is yes. We do it very similar way to blocking events and SQL session events. We use the extended events of SQL Server. Okay.
Excellent. No other questions.
And I will switch back to
the presentation.
Yes.
Yeah. So I think thank you, Marek, for this great presentation. If there is any questions that the attendees have that have not been already covered, you can contact us at support@dbWatch.com, or if you have any questions on the pricing and licensing and architecture of the product, you can also contact sales@dbWatch.com, and we can arrange a meeting with you. So thank you a lot for all attendees listening to us today. And looking forward to seeing you on the next webinar. You can go to the dbWatch webpage on the events and see what is scheduled next. And if you have also suggestions for new webinars, please don't hesitate to contact us, and we will put that into our schedule. Thank you a lot, Marek, and thank you, your attendees. Have a really nice day. See you again next time.